In continuation of dimension, the next topic is dimensional formula, dimensional equation, principle of homogeneity, usage of dimension, and example. Mainly you have to know the example of dimensional formula. First, dimensional formula. The formula which gives the formula which gives relation between fundamental unit and derived unit. Fundamental and derived unit. And derived unit is called dimensional formula. The formula which gives relation between fundamental unit and derived unit is called dimensional formula. In previous lecture we discussed fundamental unit and derived unit. Fundamental unit, the unit which are independent. In dimension, 5 fundamental units are used: length, mass, time, temperature, and electric current. That is dimension of the formula which gives relation between fundamental unit and derived unit is called dimensional formula. Next term, dimensional equation. Dimensional equation. The equation by which derived unit is the equation by which derived unit is expressed in terms of fundamental unit. Fundamental unit is called dimensional equation. There is very small difference between these two terms, dimensional formula and dimensional equation. Dimensional formula, it will write LT minus 1. This is the dimensional formula of velocity. ML T power minus 2 is the dimensional formula of force, etc. But if we express V equal to LT minus 1, then it is dimensional equation. F equal to ML T minus 2, then it is dimensional equation. Next term, principle of homogeneity. Principle of homogeneity. The power of each physical quantity on both sides of physical equation is same. That is the power of each physical quantity quantity, the power of each physical quantity on both side of physical equation is same. For example, m to the power x, l to the power y, t to the power z, and RHS m to the power 2, l to the power minus 1, t to the power 3. Then dimension of each physical quantity, that is mass to mass, meaning m equal to 2, x equal to 2, y equal to minus 1, z equal to 3. Now the usage of dimension. The usage of dimension. It has mainly three uses. First, to convert the unit of any physical quantity from one system into another. Second, to check up the correctness of any physical formula. And third, to establish any physical formula. Usage of dimension. Usage of dimension. It has mainly three uses. First, to convert unit of any physical quantity from one system into another. Second, to check up the correctness of any physical formula. To check up the correctness of any physical formula. Third, to establish any physical equation. To establish any physical formula. Now, separately we discuss the example of these uses. Example of first use. Example of first use. Example of first use. For the conversion of this unit from one system into another, a formula generally used in dimension method. The example is to convert 1 Newton force, 1 Newton force into dyne. Newton is the unit of force in SI, and dyne in CGS. Newton in SI and dyne in CGS. Here the numerical value is 1 N1 U1. N1 U1. Unit is Newton and numerical value is 1. 1 Newton. Here N2 is absent. Unit is U2. It is clear that N1 U1 equal to N2 U2. Therefore, N2 equal to N1 U1 by U2. The value of U1, where U1 equal to M1 per power A, L1 to the power B, T1 to the power C, and U2 M2 to the power A, L2 to the power B, and T2 to the power C. Write in place of N1 and N2. M1 to the power A, L1, B, T1, C. And in place of U2, M2 to the power A, L2 to the power B, T2 to the power C. This relation next step written as M1 by M2 to the power A, L1 and by L2 to the power B, and T1 and T2 to the power C. This formula is used for converting unit of any physical formula from one system to another. Now we come on question to convert 1 Newton force into dyne from SI to CGS. From SI to CGS. Firstly, we have to write the formula N2 equal to N1, M1 by M2 to the power A, L1 by L2 to the power B, L1 by L2 to the power B, T1 by T2 to the power C. Let it equation first. Given system, that is Newton in SI, is expressed in suffix 1, M1 in kg, L1 in meter, T1 in second, N1 numerical value given in 1, M2 gram, L2 cm, T2 second, N2 watt. Now write the dimension of force. The dimension of force, force mL T to the power minus 2. Now equating or using principle of homogeneity. Equating equation first and second. We have N1 we have A equal to 1, B equal to 1, C equal to minus 2. Putting above value in equation 1, N2 equal to N1, N2 equal to N1, N1 value of N1 is 1, M1 kg, M2 gram to the power 1, A equal to 1, L1 meter, T1 centimeter to the power 1, T1 second, T2 second to the power minus 2, this second is cancelled, and 1 to the power minus 2, 1 to the power minus 2 equal to 1, 1000 gram by gram, 1 meter, 100 cm by cm, 1000, 10 to the power 5. So 1 Newton equal to 10 to the power 5 dyne. 1 Newton equal to 10 to the power 5 dyne used as formula. Now the second example of this conversion base is to convert 1 joule work into erg. Convert 1 joule work into erg. Second example, to convert 1 joule work into erg. Joule is SI unit of work and erg is CGS, or how many ergs in 1 joule. First we write the formula N2 equal to N1 M1 by M2 to the power A, L1 by L2 to the power B, and T1 by T2 to the power C. M1, L1, T1 and N1, that is one suffix, is given in SI, kg, M1 kg, L1 meter, T1 second, N1 first. N1 1, M2 gram, L2 cm, T2 second, N2 watt. The given value, as you have to note from question, the given value and the converting value. Here the given value is 1 joule in SI and converting value is CGS. Erg is CGS unit of work. Now write the dimension of converting quantity, that is work. That is dimension of work, M L T to the power minus 2. Equating equation first and second, we get A equal to 1, B equal to 2, C equal to minus 2. Putting above value in equation 1, N2 equal to N1, M1 kg, M2 gram, L1 meter, L2 cm, second by second, 1000 gram by gram, 1 meter, 100 cm by cm, 1000 to 100, 10 to the power 7. That is 1 joule equal to 10 to the power 7 earth. Homework: to convert 1 pounder force, 1 pounder force into dyne. First. Second, the value of density of wood in CGS is 0.5 gram per cm cube. Convert this value in SI.